Orlando. Okay, thank you.
Yeah, got you. Thank you. All right, so game plan for today is 6.4, and if possible, I'm going to sneak in one problem from 6.5. You're actually using the same formula in 6.4 and 6.5. It just makes things a little bit easier for me next time. But on paper, at least, 6.4 today, and then we will have a quiz at the end. 6.5 Tuesday, and our next exam is a week from today, Thursday the 24th, exam number 2. Okay, so now that you've seen one exam, the exams all pretty much work the same way. So what do I turn in? You turn in 6.1, 6.2, 6.3, 6.4, 6.5, right? So you turn all that stuff in. Or in other words, this. Okay. And I shortened the assignment a little bit because I couldn't teach you guys last week. Okay, so submit this. And we can talk more about the test Tuesday perhaps, but you know what it's like. So when you come in on Thursday, I'll start you off with a question and answer session, which can last all the way up to 6 o'clock at the latest. But if nobody has any questions, we can start right away. Okay, then I'll project. So I'll do like I did last time. I'll project it here, and I take 2 parts for the test. And then while you start working, I'm going to go to Canvas, and take me a couple minutes, but I'll send the exam on Canvas also, so that way you can go to Canvas and maybe print it out, and maybe it's easier for you to look at there compared to just looking at everything on your cell phone like this. That might be a little bit tougher. Okay, and then when class ends at our usual time, 6:55, I will close the session, and then you have 5 minutes to turn in the exam. So just click through all your pages, or if you have a scanner like Cam Scanner, you can submit it that way. And then you get another half an hour after that up until, what, 7:30 to submit your homework. But if you want to submit your homework early, that's fine, like earlier in the day. That would make things a lot easier. That'll be fine too. Okay. So that's what's happening. Okay, so let's go to 6.4. It's something called present value of an annuity. And this is the only formula that you need. Okay, so never mind about the middle part. It's on page 393. A sub n is called the present value. So it looks like AN. Okay. All the other letters are just like before. R is a periodic payment. 1 minus 1 plus I to the negative n all over I. The I and the n are the same as section 2, same as section 3. I is the periodic interest rate. So they'll give you an annual rate, but you might have to chop it up into 2 pieces if it says semi-annual, or 4 pieces if it says quarterly, or 12 pieces if it says monthly, and so on. Okay? And then N is the total number of compounding periods. Okay? So it's the number of years times periods per year. Right? So let's say it says 10 years, but compounded quarterly, then you have to go 10 times 4, which is 40. Okay? One thing to watch out for in this formula, there's a negative n there. Okay? It's raised to the negative n. How they came up with the formula goes beyond the scope of our course. The book goes over some calculations of that, but we don't really need it. Okay, now 6.5 is really the same formula. They give it to you in a little different fashion, but you can survive with just this formula. Okay? I'll just talk quickly a little bit of theory. So the theory behind this kind of an annuity. So in this particular case, you are plunking down a lump sum, a big amount. So let's say $20,000. It earns interest, and then every period you take out a certain amount, okay, until it's all gone. Right? So imagine this scenario. I go to the banker. I want to plunk down, I don't know, $20,000. Okay, and then every period I withdraw $1,000. Right? But all along, it's earning interest until it's all gone. Right? So that's what's happening right here now. Okay? So we just have to take the component parts. So they might give you R, I, and N, then figure out A sub N, the so-called present value. Or they might give you A sub N, I, and N, and then you figure out the R. In fact, that's the main idea behind section 5. Section 5 is going to be like that, essentially. Okay? or in a harder case, you might have to figure out the n. Okay, so all of those are possible. So I will go show you those right now.
Professor, sorry.
Yes.
Do you mind reading that formula again? Just
Reading the formula? Sure. Okay, so A sub n, AN is called the present value of the annuity, equals R, bracket, 1 minus parentheses 1 plus I to the negative n, all over I. Okay. And again, maybe I'll do this for you. Put it on your cheat sheet. You don't want to memorize it. Well, I'm guessing you don't want to memorize it. I mean, I'm not stopping you from memorizing it, but I'm guessing most of you don't want to do that. Okay, so that's a little bit easier, but it's my own writing, which is not as good, of course. Okay, so this is called the present value. Present value of an ordinary annuity. Okay, R, I, and N are the same as before. So this is periodic payment. And I'm not going to write down I and N because it's the same as before. Interest rate per period. So it depends if it says annual, semi-annual, quarterly, monthly, right? And the N is like before. You take the number of years times the number of periods per year. Okay, so I was going to show you the evens, right? And then hopefully I have time to show you one problem from 6.5 to show you that it's really the same thing. And then there is that amortization schedule that I was going to talk a little bit more about today. And then after that, we will stop and give you the quiz. Okay, so 6.4. And again, these are my 6.4. Unfortunately, it may not match yours, but we'll do the best that we can. All right, so we had to do 3 through 10. Okay, so you don't have the even answers. Okay, so number 4. R was $3,000, and it says 6 years compounded semi-annually. Okay, so $3,000, 6 years semi-annually. What is the so-called present value? Right, so I just throw it into the formula. So 6% semi-annual means I divide it into 2 pieces. So 6% becomes 3. But when you type it on your calculator, it's got to be 0.03, right? Now, what's the N? I'm kind of covering it up intentionally. 6 years, how many times a year? Semi-annual means twice, so N is 12. Okay, so that means year 1, 1, 2. Year 2, 1, 2. Year 3, 1, 2, and so on. So grand total is 12. So I just throw everything right into the formula. So A sub n is R. They give me that as 3,000. 1 minus 1 plus I, 1.03. And careful, it's to the negative n by formula. So it's to the negative 12th power divided by 0.03. Okay, and this is the answer that they got. I'll show you quickly on my calculator if you want to follow the progression. Sorry, every time I put this calculator out, if I angle it incorrectly, it burns out your eyes. I'm sorry. Okay, I usually like to do the more complicated thing first. So let me do that first. 1 minus 1.03, oops, sorry. Exponent, okay, my exponent is that button. Negative 12. Okay, on my calculator, to get a negative, you use this button. Don't use this negative. That really means subtraction. And you can tell because it's with divided, times, minus, plus. So this is subtraction. This is to get a negative number. Okay, and let me see quickly on this other calculator. To get a negative, you have to hit this button, plus or minus. And you'd actually have to go backwards. So you folks would have to hit 12, and then this plus or minus, and then the negative pops up. Okay, whoops, sorry. So I'm only doing a numerator, 1 minus 1.03 to the negative 12. And by the way, show me all of this stuff. If you show me all this and you get a wrong answer, I will give you most of the credit. Maybe you typed it in wrong. I could type it in wrong. Okay, but if you just show me an answer with no work and I don't know how you got it, I might have to give you a 0, right? So you should be able to show me all of this. Say, oh, you got that correct. You got the calculation correct. I'm sorry, you got the formula correct. Maybe you just typed it in wrong. Okay, so I get this thing, and then I'm supposed to divide it by what? 0.03, so divided by 0.03, and then times 3,000. Okay, so times 3,000, and they're 29,862.011. So 0.011 would mean 0.01. So there it is, $29,862.01. Okay, so that's called the present value of this annuity. So we're done with the problem, it's finished, but what does the answer mean? Okay, so if I went to the banker and actually put down this much money, $29,862.01, and if they offer this annuity where I can take out 3% every 6 months, and you can take out $3,000. Okay. Then by the end of the 6th year, all the money would be gone. It'd be all drained out. That's what it means. Okay, and the problem's finished, but I'll dig deeper. How much was the total withdrawal? Okay, so I take out $3,000 every time, times 12 times, $36,000. Okay. So notice at the start there was 29,862.01, but you were able to withdraw 36,000. Good deal, right? How come you can take out more? Because all along you're earning some interest, right? So you're taking money out, but you're earning interest. Okay, and just a quick thought: do you think you're earning more interest at the beginning or at the end? You're earning more interest at the beginning because you have more money at the beginning. At the very end, there's hardly any interest because your amount is closer to zero. Okay. Okay, question number 6. Said 8.4% compounded monthly. Aha. Monthly means you're going to divide by 12. And it's for 20 years. Okay, 20 years, how many times a year? 12 monthly. So what's my N? N is 20 times 12, 240. All right, and they say R is equal to 1,000. Okay, so what is the so-called present value? And it comes out to be this thing. Let's see, how do we get that thing? All right, so this means I want to be able to take out $1,000 240 times. That's what's talking about. All right, so first I have to find my I. I take the 8.4%, which means 0.084. Monthly means divided by 12. That comes out to be 0.007. Okay, so that means each month I'm only getting 0.007, but I'm doing that 12 times. So if we multiply that by 12, that's the 8.4% annually. All right. All right, so throw everything into the formula. All right. A sub n is R, $1,000. That's the amount that I'm withdrawing from this account every time. 1,000. 1 minus 1 plus I to the negative n divided by I. So 1 plus 0.007, 1.007, raised to the, careful, it's negative n. So negative 240 and divided again by I. So this I and this I matches. So that 0.007 matches that 0.007, except for this one, that 0.007 has a 1 attached to it. Okay, and if you do it the right way, $116,076 and I guess no cents, the way it rounds off. Okay, and just for fun, let me try that. So on my calculator, I'll go slow. So I'll just do the top, 1 minus 1.007 to the negative 240. 1 minus 1.007 exponent negative 240. You can kind of see that. Whoops, sorry. 1 minus 1.007 to the negative 240. Okay, and then divide that by 0.007. Okay, and take that answer times 1,000. So times 1,000. And there it is, 116,076.004. 004 means leave it as 0.00. Right. But if this were 0.005, right? 005 means I would bring it up to 1 penny. Okay. And so in our monetary system, the smallest unit we have is a cent, right? We don't have money that goes down this far, so we round off. Okay, so this is called the present value of the annuity. So if I could find an annuity and I could deposit this big number here, 116076, or maybe it's a company or corporation or something like that. Okay. Under this scheme, I would be able to withdraw $1,000. It's earning 8.4% compounded monthly, 20 years. So every month, I'd be able to take out $1,000. Okay, the problem is finished, but notice what's happening here and the power of compound interest. How much money will I actually be able to take out? Okay, $1,000 every month for 20 years. Right, so it's 12 times 20, 240. So I can take out $1,000 240 times. That's $240,000. Right? Take a look. This is what you start off with. This is how much you get to take out. It looks like it's more than double, right? It's a good deal. Which is why, financial planners are always trying to tell you, hey, save your money, don't throw it all away. Save up for a rainy day, save up for your future and stuff like that. Now, of course, I'm not going to tell you what to do with your money, right? But some people have the attitude, oh, I got the money, I'm just going to spend it, have fun and whatever. But if you save up money and let it earn interest, and this is true, after a while, you got to be very patient. 20 years. A lot of us, I want my money now, right? Okay, but if you can wait, if you can hang on to the money, it grows, and sometimes, it doubles or even more than doubles under this scenario. Okay. So that's that. Okay, so number 8 is a little bit different. This time they give you the A sub n. So they're telling you the present value. The present value is $88,000, and then they give me I and N, I'm guessing. And now you have to figure out the R. So they said 5.8% compounded quarterly. Okay, so 5.8% compounded quarterly means I divide by 4. So 0.058 divided by 4 comes out to be 0.0145. Okay. And then they said 5.5 years. So 5.5 years compounded quarterly means I multiply by 4. Is that right? So 5.5 times 4 is 22. Okay, and let me just check something real quick. I think my book was number 10, but yeah. I think this is your 8, but anyway, $88,000 invested in annuity that earns 5.8% compounded quarterly. What payments will it provide at the end of each quarter for the next 5.5 years? Okay, so that's my 10. I believe it's your 8. But anyway, okay, 5.8% is 0.058. It says quarterly divided by 4. The N is 5.5 years, 5.5 times 4, 22. Okay, the difference is in the formula, the first two problems, they give me this, this, and this. Figure out AN. This time they give me AN. I have $88,000 presently. That's why it's called present value. And you have to say to yourself, how much can I take out every period? Right, so they're going to give me this. So 88,000 goes here. So here we go. 88,000 equals R, 1 minus 1 plus I, 1.0145 raised to the negative 22 all over I. Show you the formula again, what's happening here. So 88,000 goes here. We're solving for R. 1 minus 1 plus 0.0145 or 1.0145 raised to the negative N, negative 22, divided by 0.0145. Okay? Just to let you know, the next section, 6.5, almost all the problems are going to be like this. So we're setting up for that. You're almost always trying to figure out the R. That's not absolutely true all the time, but most of our last section's like that. Okay, this came out to be 18.72, blah, blah, blah. Let me actually try to work this out for you on my calculator, and you'll be trying to figure that out also, hopefully. So 1 minus 1.0145 exponent negative 22. Okay, so again, on my calculator, exponent is that. To get a negative is that. Okay. On this calculator, exponent is y to the x. To get a negative, it's probably this one, plus or minus. And you have to go backwards probably. Most calculators are like this. You hit the 22 and then hit that, and then the negative pops up. Whoops, sorry. Okay, anyway, I got that. And then I'm supposed to divide by what? 0.0145. 0.0145. Okay, 18.72, blah, 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 blah. 18.7212094211, whatever. Okay, now, talked about this last time also. We want the greatest possible accuracy. You do not round off your answer. Okay, so in other words, I now have 88,000 equals 18.72, blah, 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 R. So I should divide both sides by 18.72, blah, 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 blah. Don't just put 18.72. You'll get a big rounding off here. You might be off by a few dollars even. Okay, so you have two choices. Option one, sorry, write down every single digit. Okay, I mean, it's not really going to be that bad doing a test. That might take you 10 more seconds than everybody else. So you folks would literally have to go 88,000 divided by 18.7212094211. Okay, much better if you have this answer button that I talked about before. Okay, so I'm just going to go 88,000 divided by second function answer. So second function answer. And notice what it says on my calculator, and I assume many of yours have that also. 88,000 divided by answer. So by hitting answer, the calculator thinks it's the same thing as if I had typed in 18.7212094211. Right? So answer stores the last result that you have. So you can see that's a lot faster. You say, I don't have an answer button. Sorry, then you folks have to literally maybe write down on a piece of paper and then do 80,000 divided by 18.7212, blah, 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 blah. Okay, anyway, 4700.551. 551 means 0.55. So 4,700.55. So that's how much you can take out.
Professor Hom,
Yes.
I'm not getting the answer because I tried to use a calculator. So how do you do that? 1 minus 1.0145 and then to the power of minus 22.
Yes. Mm-hmm.
And then how you divide?
Yeah, get your answer first. Don't do it all at once.
Okay.
Do you have a calculator that looks like this?
Yeah.
Do you have a TI?
I don't know.
Or
I have a Casio.
Casio, that's fine. Can you type this out? See,
Yeah.
1 minus 1. Can you type out the top? And I got 0.27 whatever. Okay. And then take that answer and divide. What I'm trying to say is don't divide right here. Otherwise, you'd have to put parentheses around the whole thing.
So you just put the power first, right?
Yeah. So notice what I did. I just did the numerator, the top.
Mm-hmm.
I got 0.27 whatever. Okay.
Right.
You can look at the video later on that. Okay. And then I took that answer and divided by 0.0145. If you want to do the whole thing at once, you have to put extra parentheses. Okay. So some of you are saying, I'm not getting it. If you're trying to do the whole thing, that's why I don't advise you to do the whole thing, but I go slow. But if you want the whole thing, you have to put parentheses here and then divide the 0.0145.
Yeah, I don't get that answer.
Okay, do you get this? Do you get 0.27? Okay.
Yes.
Otherwise, come see me later. Yeah, I can't take up time, unfortunately, for individual questions.
Okay.
I have to finish the material.
Professor Hom.
Or if anybody wants to chat and give an idea about that, but I have to finish the material, please.
Professor,
Yeah.
on the calculator where it says 18.72, my calculator ends at the 2 without the 1. Is that a problem?
It doesn't have that. Okay, it probably chops it up. But when you do this, when you divide by the answer, do you get the same thing as I got here?
Yes, I do.
Oh, okay, that's good. I think the way your calculator is set up is it automatically chops all this stuff, which is nice. Where it only shows you that, but hidden behind the scenes, everything is there. So when you actually do the division,
Yes.
it keeps everything. But if you
Okay.
divide it by 18.72, you would not get the same thing.
Right.
If you just divide it by answer, I'm guessing your calculator has the answer button, then it gives you that, which is great. Okay.
Oh, okay, so use all the 5, 6, 7, or 8 following numbers behind it all the time.
Yeah, they're all there. It looks like in your calculator it's there, but it's hidden, which is actually a nice feature. And my calculator can do that also, but in case you don't, then everybody knows where to round off. You round off to the nearest penny, right? Because we don't have money that goes out to 101 whatever, right? Okay.
Okay,
Right,
thank
so
you.
there we go. So that's it. Let me just mention a little bit more again. What's the total amount of withdrawals I can take out? So under this scheme, I plunked down $88,000. Okay. If I can take out 4,700.55 every quarter, then it'd be all drained down to zero after 22 periods or 5.5 years. Okay. And the whole idea is that it's earning interest. So every quarter I can take out this much money. The total withdrawals is 4,700.55 times 22. Because under the scheme, every quarter I get to withdraw this much, like for retirement or whatever. Okay, so if I multiply 4,700.55 times 22, this is the total amount of withdrawals. Okay, so what did I start off with? 88,000. How much could I withdraw? Much more, 103, whatever. That's because you're earning interest as this thing goes along, right? So that's the power of compound interest. All right, then the last one of this type is a little bit harder, number 10. You actually have A sub n and R. Okay, A sub n is $2,500,000 and R is $120,000. Okay, so they gave that to me. So they have a lot of money. A professional athlete. Okay, well, no wonder, right? Invested $2.5 million of a bonus in an account that earns 6.8% compounded semi-annually. $120,000 is to be withdrawn at the end of each 6 months. How long will it be until the account balance is zero? Okay, so the bigger number is the A sub n, that's the left-hand side. The smaller number is the R. Okay, and it says 6.8% compounded semi-annually. So semi-annual means I divide this by 2. All right, so here's what I have. This athlete has 2.5 million. They want to take out 120,000 every period. It's every 6 months. And you're earning 6.8% compounded semi-annually means 0.034. Okay? So this athlete wants to be able to take out 120,000 every 6 months. And the question is, how long will it be until it's all drained out? All right, so 2,500,000 is here, 120,000 is here, I is 0.034. Okay, so 2.5 million, 120,000, 0.034, 0.034, and it looks like that. All right, so I divide both sides by 120,000. Okay, I'm trying to solve for n. So 2,500,000 divided by 120,000 comes out to be 20.83 repeating. Are you familiar with that bar? The bar means repeating. It's 20.83333333. So the way to write that is with a little bar there. Equals 1 minus 1.034 to the negative n divided by 0.034. Okay, so then I multiply both sides by 0.034 to cancel this out. So 0.034 times that comes out to be 0.7083 repeating. In other words, 0.70833333 equals 1 minus 1.034 to the negative n. I'm trying to solve for n. Okay, get rid of the 1. Subtract 1, minus 1 on both sides. This is a negative 0.2916 repeating equals negative 1.034 to the negative n. So there's supposed to be a negative here. There's supposed to be a negative here, but you know the trick. If there's a negative here and there's a negative here, just multiply both sides by negative 1 and you make them positive. So that's what I meant by that little plus thing. Okay. So it's not really that bad if you have negative blah, blah, blah equals negative blah, blah, blah. Just multiply both sides by negative 1 and they're positive. Okay. So now it looks like this. 0.2916 repeating equals 1.034 to the negative n. And how do I get that negative n down? You have to take the log of both sides. So natural log ln both sides. Because you might recall, if I take the natural log of both sides, that negative n gets to come down in front. So the negative n climbs down, and then the equation looks like this. Again, ln stands for natural log or log natural. They put the L first to emphasize that it's a log. Okay, so now it's going to look like this. ln of 0.2916 repeating equals negative n ln of 1.034. Solve for n, divide by negative ln 1.034. So on both sides, divide by negative ln 1.034. So the negative cancels out, the ln cancels out, so I found n. Okay, so on my calculator, I'll just hit this. So ln 0.2916. If it's repeating, I just do something like that. I just type in a whole bunch of sixes. And divided by negative ln 1.034. Okay. And again, for those of you where you automatically get the left paren, you have to close it with right parens. Okay, 36.85. Okay, so whoops, sorry. So ln 0.29166, I just put a bunch of sixes, divided by negative ln 1.034. Okay, now these are periods. Periods are always whole numbers. Okay, so 36.85, we're going to make it 37 periods. We still haven't answered the question totally. To answer the question totally, it says how long, okay, which means years. So how long is 37 periods? Well, this athlete was withdrawing $120,000 every half a year. Okay, so in other words, I divide by 2. So 37 divided by 2, so 18 and a half years. Answer is 18.5 years. All right.
Professor, you went a little fast on this one. Can I take a look at the bottom, please?
Okay, right here.
Thank you.
Is this what you mean? Okay, so the original equation was like that. 2,500,000 equals 120,000 times all that stuff. Divide by 120,000. Multiply by 0.034. I'm trying to isolate the n. So get rid of everything else, right? Get rid of the 120,000. Get rid of the 0.034. Get rid of the 1, right? From algebra. Subtracted 1. Multiply by negative 1. And then do the ln. Okay, so that's that. And back to here.
Yeah, Professor, can you show where, after you deducted that negative 1 by both sides, where it says 0.7083, then you got the negative 1 underneath. How'd you get that? So you subtract negative
0.7083 repeating minus 1 is negative 0.2916.
Okay. Can you, instead of doing that, can you just, what happens if you do the 1 minus 1.03?
Okay, you can't do that because it's tied up with an exponent. By order of operation, the exponent has priority over subtraction, so we're not allowed to do that.
Okay.
So you have to do that minus that, which on my calculator came out to be this.
Okay. Thank you.
All right, you're welcome.
Professor Hom, so in front of the 0.2916 is plus or minus the sign?
Okay, at first it was a minus. That minus that is clearly a negative number, right? 0.7 is smaller than 1.
So 0.7 is minus?
There's a negative here, and there's a negative here, which I quickly changed to a positive.
No, on the top, 0.7083, is that minus? Is that negative?
That's a positive.
It's positive.
Yes. There's no
so
symbol.
if you positive multiple by negative 1, should it be positive?
No, I'm subtracting 1 first.
Oh,
0.7083 repeating minus 1.
I see, not multiply. Okay.
Okay, and then again, why underneath do you have to do, you turn into a positive? Why is that?
Okay, you have a negative equals a negative.
Right?
Like this.
Okay.
So just multiply both sides by negative 1, and they both become positive. Right.
Okay.
That's a typical trick. If you have a negative on both sides, just multiply both sides by -1. And that's what I meant by just changing them to positive.
So when you have the negative on both sides, you automatically turn it into a positive.
Correct. You can always, that's a nice shortcut. Anytime I see this, I don't mind. I just make them positive. The step you're actually taking is multiplying both sides by -1. So if I have
Could the
negative
same-
blah, blah, blah equals negative blah, 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 just make them positive.
Could the same results have gotten by keeping them negative?
You get the same result by keeping them negative, but you're just asking for more trouble by keeping
Okay.
the negatives longer. But
Okay,
that would normally be the next step anyway. The next step is to multiply both sides by -1.
okay.
Okay, I was going to show you one thing from 6.5 and introduce it. Okay, what's happening in 6.5, it's called loans and amortization. You take out a car loan, a home loan, okay? It's something called amortization. Okay, so let's say you buy a car or you buy a house. Okay? Very rarely does anybody have the money to put the whole thing down and pay it all off. Okay? Quite often you have to borrow money, right? So you borrow money. I'm claiming that we're having the same formula. Okay, so what happens when you take out a loan, a car loan, right? So you borrow so much money, and then every month, for instance, you pay a certain amount back until it's all paid up, correct? Okay. So you say, okay, I'm financing this car. I need to finance $20,000, let's say. Okay, you're paying interest, right? And say every month, okay, every month you have to pay a certain amount, blah, 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 and until it's all gone. Okay. What I'm claiming is this situation is really the same as 6.4. The bank is taking an annuity out on you. Okay, so when the bank gives you the $20,000, it's like they're doing 6.4, and then when you make the payments, right, that's just like the bank is making withdrawals, and all along the time, the bank is earning interest on you, right? Which is the whole idea why the banks are doing it. They're earning interest as they're lending you the money. So it's like the bank is taking out annuity on you. So they're giving you the money, and then they are making withdrawals in the form of you paying every month, the loan amount until it's all paid up. So in other words, 6.4 and 6.5 are really the same thing. The language might be different. Okay? They'll say, okay, you're taking out a loan for so much money, so much interest, so many years, blah, blah, blah. That part's the same. Okay? How much is your periodic payment? Okay? As you make the payment, that's sort of like the bank is making withdrawals on its annuity until it's all gone. Okay, the loan is all paid off. But in the meantime, the bank is earning all this interest on you and me, right? That's the whole idea behind what's going on. So I'm really claiming 6.5 is the same as 6.4. So I was just going to show you one problem there and talk a little bit about this table. Okay, so I'll talk about that table and then I'll give you the quiz. And we have time for that. So 6.5, I was just going to do the first one, which I believe was number 4. Okay, so let's look at the language. A loan of $10,000 is to be amortized with 10 equal quarterly payments. Now, when they say it like that, N is already 10, equal quarterly payments. Okay, we do have quarterly, so we have to chop up to 6%, but you don't have to chop up or multiply by the 10. It doesn't say 10 years. It says 10 payments. So that would be what, 2.5 years? You don't really need to know that. Okay, interest rate is 6%, compounded quarterly. What is the periodic payment? Okay, this would be like I'm borrowing $10,000. Okay, I make my payments every quarter, 6% compounded quarterly. How many payments? There are 10 payments. So what do I owe each time? Okay, so here's the key information. So A sub n, the present value of the annuity is $10,000. That's like the bank is giving you $10,000. It's investing $10,000, okay? And it's going to withdraw. It doesn't really withdraw. The withdrawals are when you make the payment. When you make the payment, that's like the bank is making withdrawals. And there's going to be 10 payments. 6% compounded quarterly means that divided by 4. That's all the same. Okay? So 0.06 divided by 4, 0.015. Okay, that's a little I. And I use the same formula. Okay, so the amount of the loan, so-called present value, is the $10,000. Okay, this stuff is the usual. They said 10 payments, and we figured out the I. So all of that goes in the formula. 10,000 equals R, 1 minus 1 plus I, 1.015, raised to the negative 10, divided by I, 0.015. Okay, once again, this comes out to be not a nice number, 9.222 or whatever. And again, I'll try to show you if I can get that. So I like to just do the numerator. So 1 minus that, 1 minus 1.015 exponent negative 10. Just the numerator, 1 minus 1.015 exponent negative 10. And by the way, when you do it for me, show me all these numbers. Show me that, so I can give you partial credit in case it's wrong. And you can show me this number too, 9.222. Oh, I didn't divide by 0.015, right? So divided by 0.015. So I just typed that in, got that answer, and then divided by that. There it is, 9.222164, blah, 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 blah. So I have R times 9.222. So to solve for R, I divide by that 9.222. Keep every digit for greatest accuracy. So you have two choices. Choice number one, use the answer button. You say, I don't have an answer button, and sorry, you folks would literally have to type out, what, 9.22218455185. You lose, I don't know, 10 seconds per problem. It's not that big of a handicap. But for those of you that have the answer button, okay, then we're just going to go 10,000 divided by answer. So 10,000 divided by answer button is down here. So second answer. So see how it says divided by answer? That's the same thing as if I had typed 9.222184555, blah, blah, blah. Round to the nearest penny. So the nearest penny is 1,084.341, means 0.34. All right. So that's the payments that I have to make, the periodic payments every, what was it? Every quarter. Okay. So if I needed to borrow $10,000 under this scheme, okay, at, what was it? 6% interest compounded quarterly. Okay. This is the amount that I have to pay until it's all paid off in 10 payments. Okay, what's the total amount of money that I pay back? So I have to pay this amount 10 times. So that times 10 is 10,843.40. Okay, so how much did I borrow? 10,000. How much do I pay back? More. It's always that way. Never fails. Hey, the banks are out to make money, right? So if you borrow a certain amount, the total amount you pay back, it's always more. Okay, when you buy a house, same thing. Right? I can't afford to pay this house, so I pay it back in periods, and the total amount that you pay is usually way more than the amount that you borrow. Okay, so you can see it's really the same kind of problem, right? Same problem, but for right now, I am going to spend a little bit of time talking about this table. So I want you to at least see it, so you have at least a week to see it. If I wait until Tuesday, then you only have 2 days before the test. Okay, so I'm going to show you this, so at least you've been exposed to it, you know, now. All right, so this is called an amortization schedule or amortization table. You can copy this exact same thing onto your formula sheet. Okay, period, payment, interest, balance reduction, unpaid balance. Now, for this particular case, it looks like you were borrowing what? $10,000, 10%, 5 equal annual payments. Okay, so I is 0.10. So they threw it into the formula, right? Blah, blah, blah. Comes out to 2637.97. That's the amount that you pay in 5 payments, sort of. Okay, so let me show you what's going on. So what is this? So we have 5 periods, right? So you start off with $10,000. Okay, now I'm making this payment from the formula, 2637.97. However, you don't get to subtract that total amount every time, because the first thing you have to pay is the interest. That's the key. So first, in this case, the periodic interest was 10%. So first, you have to figure out 10% of 10,000. That's just 1,000. right? 10% is easy. The next problem might be 7%. The next problem might be 5% or whatever, okay? So you don't get to subtract this total amount. You first have to pay $1,000 to interest. So notice if I take off 1,000, it's now only 1,637.97. Okay, so this column is payment minus interest. Okay, so you take this thing minus this. How do I get this? You take the unpaid balance times the interest rate, which is 10%. So 10% of 10,000 is 1,000. This is the amount that you get to subtract off the balance. So now if you go 10,000 minus 1,637.97, it comes out to be 8362.03. Notice I could not subtract the whole thing because first I have to pay off the interest. Then you keep doing that. So the next period, same thing, 2637.97. By the way, you may notice the last payment may not be the same. Okay, it might be a little bit above, it might be a little bit below, it might be exactly the same. You can't tell until you do it. This is a little bit off because we cannot go out to every last digit. In other words, we round to the nearest penny, right? If you could go 8362.0331652114, if you literally had money that goes out that far, this would always match. But generally we don't, right? So this is the best we can do. So you make this payment, but again, the first amount that you have to pay is the interest. So you take 10% of this. So 10% of this is 836.20. Okay. Then you subtract payment minus interest. So that minus that is 1801.77. That's the amount that you get to subtract. So if I subtract that from 8362, it's 6560.26. Okay. By the way, you may notice as time goes by, are you paying more or less interest? Take a look. As time goes by, you're paying less interest, which makes sense because you owe less money. That's always true in a loan. If you take out a car loan, home loan, or whatever, the biggest amount of interest is always at the beginning. It isn't until the end that the interest, starts to drop. Okay, so you keep following that process. You make the same payment. Now the interest is 10%, but it's no longer 10% of that. Now you only owe this much. So 10% of that is that. Subtract these two numbers. 1981.94 comes out to be that. Now you follow that process all the way through until the end. Okay, this last part is tricky. Let me cover up the last one. Pretend we don't know that. Okay, this last payment, it might be 2637.97. It might be a little bit more. I notice in this case it's a little bit more. It might be a little bit less. So what you do when you're making this schedule, and you have to be ready for this on the test next Thursday, so that's why I'm showing it to you now. And we'll do a couple more examples on Tuesday, but at least you've seen it. So you have at least a week to prepare. Cover this up when you're making this table. Here's what you do to get this. Do the interest, so 10%. 10% of that is that. I notice it's rounded off. There's a lot of rounding off here because we only have money that goes out to the nearest penny, right? Okay, this number will always match this number. Okay, can you see why? This has to match that because at the very end, there's no more money left, right? I've all paid it off. So how much do I reduce the balance by at the last period? I reduce it by the whole works. So 2398.18, it has to match 2398.18 here. So if I subtract 2398.18, I'm left with 0. Okay, that's the way it's supposed to be. Okay, so one more time, for that last calculation, the very last period, do my 10%. This example is 10%. The next example might be 8% or 5% or whatever. Okay. This number matches that number because when you subtract, you get 0. Now, can you guess how to do this now? It was always that minus that is that. That minus that is that. That minus that is that. So now if you don't know what this is, can you guess how do I get this right now? You add these two numbers. So I add 2398.18 to 239.82, and it comes out to be this. As you can see, it's close. It's off by only, what, 3 cents, I guess? Okay. It might sometimes be exactly the same. It might be a little bit less, but be that as it may. Okay. Then we have the totals here. The total payment was this. What was the interest if you added it up? 3189.88. The balance reduction, 10,000. Well, that makes sense. You started off with 10,000. Hey, I want to end up paying off 10,000. So this should always match this. $10,000 I owe. How much do I reduce the balance? $10,000. How much do I end up paying? 13,000 plus. Right? So the difference between these two, as you can see, is the interest. Right? So I borrowed 10,000. I end up paying back 13,000 and more. That's always that way. Whenever you take out a loan, it's always that way. You pay so much money in interest. Okay, so I know I went through that quickly, but at least I want you to see that concept. We will do more of this next Tuesday. So Tuesday, I will do some more 6.5, and I'll show you a couple of these. Okay, I'll show you a couple more where we're going to work these out in their entirety. Okay? All right, but right now I'm going to stop, and we're going to take the quiz. Okay, so get your cell phone out and take a picture of this, and then I'll break you out into your breakout room. So we have about 20 minutes for this. And again, this isn't due. It's not going to be due until Tuesday's class. So what, 5:40 on Tuesday? So you have plenty of time. But a lot of you just finished it off and submitted it. That's perfectly fine. Okay, this is all on simple interest. So take a picture if you would. Okay, find the simple interest if $4,000 is invested at 7% interest for 6 years. Okay. 2, an investment of $5,000 grows to $6,000 after 10 years at simple interest. Find the annual interest rate. So this time you're trying to find the rate, it looks like. Okay, and that's it. And this is all simple interest. For number 2, they don't give you the interest, but you can figure it out. That's my hint for that one. Okay, so I'll leave this for another few seconds. And this is being recorded also, so if I went absolutely too fast, you can look at the recording a little bit later. Okay, so I'll give you a few seconds more to get this, and then I'll put you in your breakout rooms. Okay, and I'll keep blabbing. So I'll put you in your breakout rooms, but if you're comfortable with everything, you can just leave, and then I'll see you next Tuesday. You can talk about it up until 6:55. I'll close out class at 6:55 as our usual time, but if you want to leave before then, that's perfectly fine too. I'll be in the main room, so if you ever want to get me back and you're in your breakout room, that's fine. Yeah, all quizzes from now are individual, so everybody turns in their own quiz, but you can help each other out. Okay, so I'm going to stop the share. I'm going to stop the